Okay, everyone, so we are in the final part of notes when it comes for forensic toxicology. But before we get started, I want to ask you a few questions just to kind of jog your memory about what we talked about in part 1 and part 2. First off, I think it's very important that you know the 4 factors that influence or that can affect how intoxicated a person is. And I ask that, and I want you to remember that because that is a question you'll see on the exam. All right. So let's get started. Let's look at the role of the toxicologist. So as you know, a toxicologist is a scientist and they're going to be working in the field. But if you think back way to the beginning of the year when we looked at different career fields, a toxicologist is someone who's going to be looking at bodily fluids, tissue, organs, just all over the body for drugs and or poisons. Now, a toxicologist, because we are looking at body fluids, can be someone who deals with living tissue or dead tissue or a living person or a dead person. It just depends on the type of fluid we're looking at and the type of case. It may be someone who's been dead on the floor for 3 days, or it could be someone who's been brought into the hospital and we're just trying to find out what's in their system. Now, they can conduct those post-mortem pathological examinations to try to see either what was in a person's body system that may have led to their death, or looking at containers that may be left at a crime scene to see what possibly could have been in those containers. Now, they may have to test extremely minute or tiny quantities. That's because there's not always just a giant pile of something laying around. It may just be just a few grams of an object or substance that needs to be tested. And then finally, they're going to have to detect it, identify it, quantify it, and then access this toxicity. Meaning, first, can we find anything in the system or in those fluids, whatever we're testing? Then we have to figure out what it is. We have to figure out how much there is in the body. And then we have to assess how toxic it is. Like, did we have too much or not enough? Now, in the past, I would work with one of the chemistry teachers on a Mole Airlines death investigation where all of our administrators would be victims of a plane crash, and you would have to determine if something was considered toxic or not. But because of COVID and because of the virtual learning, it's just too hard to get that to those kids that are at home. So we're not going to be able to do it this year. But I think because we're not doing that this year, I'm going to try to find some other activities where we're still collecting and preserving and really testing those chemicals. All right, so let's look at when it comes to collecting and preserving those toxicological evidence. When possible, we want to collect both blood and urine. And that's because if you think back to our last lecture, anything that's in the blood is going to be directly related to what the brain is affecting. And we know this blood is going to circulate throughout the body, but we also want to, if possible, collect urine samples because your body is filtering your blood in your liver and in your kidneys, and so it's going to be excreting those items that are in the blood to get rid of them. Our body wants to be normal. And then it's best if you can collect what we call 2 void samples of urine in a separate container. So if you have a living specimen, you would have them pee, you would give them 2 cups, and they would pee a little bit into that first cup, and depending on how good they can control their bladder, they would pee into a separate cup, and that would be the sample that you collect, and then you would pee back into that original cup. And we say that because what's at the bottom of your bladder per se may not always show what's at the highest quantities. When we collect that sample of blood, please note that it's always going to be a doctor or some type of registered nurse or physician that's going to be doing that. It's not going to be a random police officer on the side of the street asking you for a blood sample. It will be someone who is licensed and trained to take blood samples. Now, when it comes to techniques in toxicology, this is just kind of a reminder. You don't really have to write this down, but drugs can be are chemicals, and they are chemicals that are categorized as either an acid or a base. And if you think back to chemistry, an acid is any kind of compound that's going to donate hydrogens, and a base is a compound that accepts hydrogens. So the way I always remembered it was AD, the acid donates, and then BA, the base accepts. All right. And earlier this year, we talked about the pH scale. So if you have to write this, it's probably because you don't remember. But the pH scale does tell us how strong or basic a chemical is, and it goes from a scale of 0 to 14, with 0 being the most acidic and 14 being the most basic. Another term for basic is alkaline. Anything at 7 is neutral, and the farther away you go, the stronger the base or the stronger the acid. It might be anything below 7 is acid, and anything above a 7 is a base. Now, our blood is slightly alkalinic or basic. Blood is at 7.45 pH normally, and it can range anywhere between 7.35 and 7.45, and that's all depending on if you're taking medicines, and sometimes a little bit higher, like I said, depending on the medications that a person may take. Now, when we're looking at techniques in toxicology, this is something that you must know. It's a screening test, and it's called thin layer chromatography. I also call it TLC here. And you'll see a video of thin layer chromatography. It won't be the actual, it'll just be a visual representation of what takes place. But basically, we separate those molecules up through a thin coated plate. I'm going to do a demo, and it's just going to be on paper with some markers. But if you're anyone who's an artist, if you're an artist, you know that black as a paint is all the colors mixed together. So if I were to take a black marker and use acetone, I could separate all the colors out for that black marker. So in the next week, you'll see a video, probably on Friday, of me just doing a demo lab that shows that even if I use 3 different types of black markers, like 3 different brands, the way that the black is made up, the subunits, may be different. And so that's how we can determine what chemical it is. Now, for thin layer chromatography, it can be a solid or a liquid. If it is a solid, usually we make it into a liquid by adding deionized water. And then we just look at how far those different components travel up the substrate or the plate or the paper, and that will help us compare it to those known samples and then figure out what it belongs to. Now, there's gas chromatography. It's the same thing as the thin layer chromatography, except for instead of liquid, it's moving from liquid to gas. So if we look at hydrogen sulfide, it's sulfur gas and hydrogen gas. So we would break it up because those molecules are different sizes. We could see what molecules and elements are making those up. All right, and then lastly, we have immunoassay. This is used when we're trying to look at drug antibody reactions. So when they ask you for, like, if you watch those shows like Grey's Anatomy or The Good Doctor, you'll hear them say we want to type and cross match, and that's basically what we're doing. We're looking to see if, what antibodies are in the body and how it can detect different levels of drugs. All right, so you don't have to write this down as a whole page, but you do need to know that the confirmation test would be the gas chromatography or a mass spectrometry. We're not going to do any of these as a lab. You just need to know the name. So all you need to know is gas chromatography, mass spectrometry. Those are 2 different items. If it's gas or a solid, that is our confirmation test to be like, yes, this is that drug or this element. All right, so moving on, let's look at detecting drugs in hair. So before we can get into talking about detecting drugs in hair, I want you to know that drugs remain in your bloodstream for up to 24 hours. And that is like your specific bloodstream because your blood is traveling through your whole body. If you ingest it or you inhale it, it's going to go from your heart to your lungs, to your head, to your legs, to your toes, all the way through. But it usually takes about 24 hours to filter the blood. But that blood has to be filtered somewhere, and it's going to usually wind up as urine. And it usually takes up to 72 hours for drugs to kind of disappear from urine. And I say that, and I said up to, it just depends on how much you had and the consistency, the frequency, and the quantity of something that's filtered out of your blood. Because your urine, if you use the restroom, you're not getting rid of everything in your bladder. Your bladder always leaves about 10% behind. And then if you have ever gone to the restroom and you've sat there and you thought, okay, I've gotten rid of everything in my bladder, and then you wait another second or two, maybe minute, some more urine comes out, it's because your body is now going to void all but 10%. So it takes a lot to really empty urine out of your bladder because your blood is constantly being filtered. Now, getting back to hair, drugs can be permanently trapped in your hair as the protein actually hardens. And as your hair is growing, the drugs kind of tell like when in time you did it. So if you have hair that's only an inch long, think about how long it took for you to grow an inch worth of hair. And that can really tell us when you partook in any substances. But I also want to point out that sometimes drugs can enter your hair's surface, like the outer layers, like the cuticle and the cortex, not so much the medulla area. It's not going to be towards that center portion. And if you hear, I'm using those terms back from the hair unit. So the cuticle is that outside layer. Sometimes, depending on your environment, you can leave chemical residue on your hair, as well as if you're sweating. So think about it. If you've ever gone to the gym and you've had a really good workout and you're sweating, like, where is it going? If you're sweating from your head, it's being absorbed into your hair. So it does leave a little bit of a marker. And then if you live in an area where there's a lot of high vapors in the air, that can be settled and deposited on you. Think about it. So how do you know these kids kind of maybe have a smell of some herbs that shouldn't be used? You can usually smell it on them, and it's going to be trapped in their hair as well. When it comes to detecting non-drug poisons, like things that are ingested on purpose, I do want to point out that heavy metals like arsenic or mercury can be detected. Arsenic and mercury aren't used as much now. We don't see those in products. But in the past, radium was used in watches. We see arsenic that was used in rat poisoning at one point. And mercury, we no longer use mercury thermometers. We use digital ones because we were realizing people were being poisoned by those items. And then a more common thing is carbon monoxide. This is the most commonly encountered poison. Most homes now require that there be a carbon monoxide monitor of some sort. It sounds almost like the fire alarm, just to notify the occupants that there is a high level of carbon monoxide. We see carbon monoxide from the fumes of automobiles. But what's really neat is a woman who is pregnant can actually detect carbon monoxide because her blood is double filtering the oxygen in the air. And she usually wakes up, especially if she's asleep, she'll usually wake up before the family or even the alarm goes off for showing that there's carbon monoxide because the baby's oxygen supply is provided by the mom. And then she feels that discomfort and unrest. It's a pretty cool thing about science. Lastly, just the significance of those findings. Once we identify a drug, the toxicologist must assess and influence its behavior on the individual. You know, did you take one baby aspirin? Okay, it's a small blood thinner, but is it going to kill you? No. Versus, you know, did you take a pound of herb? Did you take a pound of marijuana, grind it up, and then smoke it all? Of course, it's going to have a different effect on you than if you just walk by it because someone, you know, had it on them and was smoking previously. So that's something that we always have to look at when we're identifying drugs to determine, was this a factor in the incident that caused us to have to test for it in the first place? All right, so here are my references for you and your sources. I had a few others, but I decided not to put those on there. I hope you have a great day. Make sure you've taken notes. All of the notes will end and disappear on April 9th, which is next week, because you're going to be taking a test over them. If you have any questions, as always, you can always reach me by messaging me on Schoology, which is usually the fastest way. You can also join the homework room after school from 4:15 to 8, which I'm always online, and you can always join in the morning. All right, have a good night, guys.